So yeah, feature stores, it's not just about storage. I would argue and have argued that feature stores, it's kind of this misnomer that we're kind of are sort of stuck with, because it's a very hard thing to change the name of a category after it's been created. But I think that when people hear feature store, they think of a specialized database to store features. And I don't really think that's a problem to be solved. When most people think of feature stores, they think of something that looks like this. We call it a literal feature store. If you've ever used something like SageMaker or Databricks' feature store, it kind of has an architecture which sort of mimics this. Again, everyone does it a little differently, but I would say generally it looks like this. And how that looks like is you take your data sets, you would transform them to build your features, and you treat your features as this kind of final artifact that goes into the feature store. And the value there is that all of your features are in one place. They can be served both in kind of OLAP style fashion for training and in transactional fashion of low latency for inference for models that are interactive, like a recommender system or a fraud detection system. The problem here, which I'll get into, is that the feature is treated as this final artifact. Like we're treating the feature as like a row of data, when in practice, the feature is almost always actually tied to the definition, this idea of the transformation. And if you don't tie the transformation to the feature, you end up in kind of this high friction area, because a lot of the value of features is the ability to, like the point of the feature store is to increase iteration time, or rather decrease iteration time, increase the number of iterations. And if you have to constantly switch back and forth, it causes a lot of pain. In practice, especially for a production feature, we have a set of features that are batch. We have a set of features that are streaming. And we have a set of features which can only be produced at request time, or on-demand features. These would be things like if you are doing fraud detection, you might take, or let's say actually you're doing something where you're checking a comment for hateful speech. There's some features you'd probably create off of the comment itself. That you can't pre-process that, right? Like that has to happen at request time. And that would be the case for on-demand features. There are a lot of features which, let's say they have like long window time, et cetera, which can be done via batch. And there's a set of features which really benefit from having near real-time, up-to-date, fresh features. So on the left side, these are features that can be pre-processed, and the kind of decision tree of whether to use streaming or batch is really how much does freshness impact the features or the model's performance, or that feature's performance towards the model. Great. So let's talk about the actual workflow of building features. A lot of people, when they think of feature stores, they think of kind of that production, like I built my feature, now I store it in the feature store. But again, lots of the point of building features is the kind of constant iteration of features. And this is actually what I see in practice. Even if you're using a feature store, you end up with something that looks like this. So let me break it down. There's this fence in the middle, which I so artfully put together. But I'll start with the top part, which is the experimentation piece, which is actually where most of the time is being spent, like where most of your time as a data scientist is being spent. In that world, you're working with a lot of notebooks. You are interacting with your infrastructure to build, or maybe even just working locally, to come up with signals that you feed into the model, the features. Some of them are interesting, some of them aren't. You may be interacting with a set of bash scripts, Airflow jobs, etc. But once you find something interesting, what I see in practice a lot is you actually have to throw that notebook or something over the fence to some other team that has to then go implement it. And no one's happy because oftentimes they screw up. And oftentimes they're like, what is this kind of garbage notebook that I've just received? I have to somehow like cross-write into Scala for our production pipeline. So this is where a lot of the friction comes from. And just having this kind of literal feature store, this place where you just store features, doesn't solve this. Because you still need to handle cases where you have streaming features. You still need to handle on-demand features, which doesn't really exist in the experimental function. It's almost like you're still having the problem of writing two different pipelines, and oftentimes even having two separate teams to handle building or coming up with features and getting those features in production. If you have dealt with this, then this might resonate. One of the big problems is that I think as MLOps practitioners, we really get caught up. I mean, just as engineers, I think we like working on what I would call the data processing side of things. How do we do streaming faster? Like, how can we use whatever cutting edge new framework? We can use Rust to make this, 10% faster to handle however many exabytes of data. The thing is, though, that most of the problems that I see companies face is actually more of a workflow problem. How can we get N data scientists to work together to collaborate? How can we make it so that the workflow of getting a feature all the way from experimentation, ideation to production to be something that is very clean, has clear flow, has clear history, lineage, versioning, governance, monitoring, all the pieces that would be required. How can we get all of that to work together seamlessly? It's not necessarily that the problem is so much that, oh, Spark isn't fast enough. If only we had a better Spark, or if only we had a better Flink. It's really, how can we make all of these disparate pieces work together in a workflow that is coherent from end to end? It's a workflow problem. And I think most MLOps problems are, in practice, workflow problems and not infrastructure problems. And I think that we get too caught up with building new cutting edge infrastructure, and solving people problems is much tougher. It's really hard to come up with the right APIs and the right abstractions. And I think that for the feature store case, we've come to the wrong abstraction. And I think that it's kind of time to rethink what a feature store is. I know there was a talk earlier about the logical feature store. We call it the virtual feature store. And I think that is kind of the direction that as an ecosystem we need to move towards. These are things that traditional feature stores don't solve. Sure, you can go and you can write your feature to this new sync, which is a feature store. But think of all the things that you did on the way. Your untitled notebooks, your DF finals, your feature table V7 that's in Snowflake or wherever, even if it's in the feature store, it's still called feature table V7. You have these random scripts to trigger materializations, these ad hoc Spark submits, all these problems, and no documentation. It's not really built into the workflow because the feature itself is an artifact which is separate from how it was created. So even if you find a feature that may or may not be relevant, you don't really know what this thing is, how it was created, where it came from, how to rebuild it. You're kind of in this situation where technically your feature is now in production. You can train a model of it. You can serve for inference, but the workflow is just broken. It's just completely ad hoc. If these things, just a few more memes, I promise. If these things look familiar to you, then you likely are facing something that may or may not look like what I'm describing. This is not something or a set of problems that is unusual or something new. In fact, it's interesting if you kind of roll back time and look at the first feature stores that were built internally at companies. Companies like Uber. In my last company, we built a feature store. They would look like, we call it a physical feature store. Some people call it feature platform. But the idea of tying the transformation to the storage is actually the more common paradigm that we see. even in companies that have literal features, so like even if you look at like companies that have open source feature stores, it's actually only one team and the other team did the transformation piece. So internally, even though there's two separate pieces, it still looks like this. And the idea of this is now you're actually iterating on features as logic and not iterating as features as like this row of data that gets outputted after your pipeline. This really makes things better, especially when you're dealing with streaming features, real-time features, but just even in general, just the iteration, you get the lineage automatically, you get all of the stuff that you would expect, and the workflow becomes very clean. But there's another problem here. This works really well internally in the sense that if you have a team that builds this thing and maintains this thing, you can get away with rehousing all of your data on your own internal platform. However, as an external vendor, if you're looking at using an external vendor, like let's say I come to you and you, wherever company you're at, you're a larger company, let's say, and I say, hey, to use our feature store so that you get all this ability to define features, to manage features, to serve features, to do all the things you would expect, you need to actually move all of your data onto our infrastructure. And then you need to transform it via our infrastructure. And we kind of own everything end to end. It's a hard sell. Internally, if you're an internal team, you can do that. You get more buy-in because in the end, you own the thing. It's your code. As a vendor, it's a hard pill to swallow. And in practice, there's only so much value you get from doing this, right? Because your problem, it's the wrong puzzle piece. Your problem is not that, oh, we don't like Redis. Redis isn't fast enough, or we don't like Spark. We need something else. We need to build something that is completely new, a whole new type of Spark or a whole new type of Redis, which is better than what exists today. Some people may have this problem, but I would say that the majority of companies that use us, that we talk to, don't. It's not really what they're facing. Another kind of common thing that a lot of the feature store that I've seen talk about is making everything streaming. And I get it. Like theoretically, like streaming is a superset of batch. So like every batch problem can be actually defined as a streaming problem in almost every case of a feature. In practice, though, like that's like a nice theoretical world. In practice, batch is way easier. And if you can get away with batch, you should probably use batch. And only when it makes sense to have streaming should you use streaming. And in practice, what we see is like 5% about on average of features at most large companies are actually streaming. In practice, almost everything is batch, and there's not really much value in taking those batch jobs, rewriting them, making them all streaming. Finally, the last kind of wrong puzzle piece is that, oh, what we're missing is this new type of storage layer, which is just where we put our pre-computed features. That's a feature store, as the name implies. And again, it's just not really solving the problem of how do I iterate quickly on features? How do I keep features reliable? How do I collaborate on things, which would require having things like lineage and governance and et cetera. It's really just like a new type of database, which, going to the first point, isn't really the problem to be solved. And as I was thinking about this and thinking about the fact that, hey, we built a physical feature store, that feature platform, but in practice, it's not what people really need. In my opinion, like externally as a vendor, I just don't think it makes sense to force everyone to rehouse all of our data onto us and for us to actually do the transformations and to create some new DSL that every data scientist has to learn. So we came up with this idea of a virtual feature store where you have a declarative API, which you can define and manage your features in. Literally where the idea of Featureform and the name came from was I wanted Terraform for features. And that's kind of what we ended up building. Something that looks like Terraform, but built for feature pipelines from end to end. So you can define your features, define your labels, define your training sets, define your transformations. You get built-in collaboration, versioning, et cetera. You get monitoring and alerting built in. Pretty much add this layer, this application layer on top of the feature store infrastructure and use an orchestrator to make the underlying infrastructure work like a feature platform. That was kind of the premise of this. And it works really well because what we're trying to solve here is solve the workflow problem. How can we make all this stuff work together cleanly? And you can solve things like point in time correctness. You can solve things like backfill, etc., without having to actually replace all the infrastructure. Especially in situations where companies have like an on-prem and then in cloud, or they have situations where they have, Dynamo for some features, Redis for others. Like there's way more complex deployments in the real world. And really what people are looking for is one pane of glass to define and manage and serve these things. And that's what Terraform's promise is for infrastructure. And I think we needed the same thing for features. And that's the kind of premise of the virtual feature store. And again, to the point of the thing, the feature store in this case is almost a misnomer. It's not about storing features in the sense of like a row of data. It's about storing features as this definition, treating like a definition language and building in all of the components you would expect to exist in an ML feature, around an ML feature, from governance to monitoring to collaboration. Yeah, a little quick, but I actually left a little bit of time for questions. I can kind of go in a lot of different directions here, depending on where people want to go.
Brilliant. Thanks a million, Simba. Great to have you back again.